Um, Good morning, everyone, and thank you for joining us for this week's Lunch and Learn. I'm Tony Ross, Director of Communications at Preventative Research. Before we get to today's presentation, I want to talk about another presentation we're going to have coming up in 2 weeks. John, can you see my screen?
Yes.
Okay. So in 2 weeks, we're going to be having another Lunch and Learn on March 16th from 12 to 1 p.m., the same time as this one. The presentation will be, what can you learn from 100 novels? This is a research project that was done a couple of years ago. It's a text analytics dictionary approach. You can register on the webinar section of the Preventative Research website, the same way as you did for this presentation. And the presentation will be delivered by Martin Glisserman and Abby Jones. John, and put up your screens.
Okay. All right.
Now to today's presentation, which is titled Managing Project Risk Using the Voice of Team, VoT, and Text Analytics. Dr. John Aaron is our presenter. John has a PhD in economics and is a 26-year veteran project management and data science consultant. Since 1995, John has served a variety of organizations as a contract project manager and as a software solutions provider, specializing in enterprise project management, business transformation, project stakeholder decision-making, project leadership, project management machine learning, and project management data analytics, SAP ERP implementation management, CRM, IT infrastructure, and data analytics. We're very happy to have John with us today to share his project. And I'll now turn the presentation over to John. As I said before to many of you, we will take questions at the end through the chat feature on the bottom right-hand corner of your screen. Take it over to you, John.
Okay. Good morning or afternoon, everyone. Pleasure to see all the attendance here, and hopefully I'll have something of interest. As Tony mentioned, I'm a contract project manager. I've also been last 5 or 6 years been a professor in data science, adjunct professor. And so Wordstat and the Preventative products have really been my tool of choice for myself and my students over the last period of years. And so that's kind of where the relationship came. But I also use the tool very much in the work realm. And what I'm going to be showing you is the application on project management, especially large enterprise type of items, and the measurement of risk. And I'm hoping that you'll get more out of this than just project management use of text, but a more generalization about some interesting concepts that I see in business. So essentially, the highlights, a point to note that I think may be useful for you is I want to demonstrate using Wordstat the combining text analytics with time series. In other words, not just a single point in time, look at number of words and dictionaries and so on, but how do those things change over time? I think what you'll see, if you have never thought of it this way, it provides some useful things, useful insights for you. I'm going to show you why I think that's important. I'm going to talk about a project management example, real life of this. Also talk about the use of machine learning in this regard, and I'm going to talk a little bit about use of Bayes' theorem for weight of evidence measures to separate signal from noise and risk. And then I'll try to generalize a little bit to the general community about using these approaches in social media, email, and so on. And I'm going to address because I'm a statistician as well, I'm going to address possibly a counter argument or a qualifier to the term, the wisdom of the crowd, meaning that when you get a lot of people, their collective wisdom usually is greater than that of a single person. And I'm going to qualify that just a touch. So a little background in terms of what project management is. This is kind of a business process. Think of it this way. And, there is a professional association of project managers and so on. And so basically when you do something and running a project and manage them, you define the scope, you plan the work, the team executes the plan, and you get these exceptions to plan that you have to take advantage and try and get them out of the way because they're blocking you from executing your plan. And some of these can be risks, and those are the trickiest ones because they kind of force you to think I would say a higher level of thinking of trying to anticipate what could go wrong. And what I've found is that the individuals on the team are a very, very useful source of that. and how do you extract that information and analyze that information? So projects are very important to our economy. And so I think this is a useful business process to leverage. And the PMI, the Professional Association of Project Managers, they talk about maturity in this regard, where you go from initial organizationally through various levels of maturity to what they would call optimizing. And what they say is that the cost, you could call it the non-conformance cost, the cost of rework and so on, the higher you get, the more mature you get, the lower the cost and the lower the variation, right? So that's kind of the way this works. And the way they look at it is there's two dimensions. One is risk and the other is quality. And what you can see is the two kind of go hand in hand. So if in fact we can come up with a way of managing the risk and reducing risks, we should in fact be reducing costs and making things better and become more competitive for our company or whomever, our client, whomever we're working for. So it has a lot of relevance to it. And the tricky thing about managing projects like this is that the risks, it's the ones you see readily on your schedule or whatever, those are usually not the ones that are going to hurt you. It's the ones that are not readily discernible, that are less visible. So kind of like this iceberg metaphor has some relevance in that there's all sorts of, a lot of times people say, well, we have a project schedule, and that's wonderful, you follow it, but it's what's causing these emergent problems that makes it so difficult to manage, especially when you're dealing with large scale business transformation types of endeavors. And so I kind of go like this, that and over the years, and you can just look at me and I'm not a spring chicken, right? But the way these things I've learned over time they go, it kind of follows this visual by Escher. And that is what happens is that risks, when they come up on projects, they're often not really discernible. You wonder, is this really a problem or is it not? And then it gets discernible more and more and more. And finally, it kind of blows up in your face. And so the idea is, can you stay ahead of these things as they emerge and somehow separate the signal from the noise? You don't want to be chasing your tail, trying to solve every problem that is down in this category, right? It may not be a problem. It just might be a person's perception or something. But this idea of the team having good insights and being able to extract that information and then have a statistical method and a series of tools such as Wordstat, which is my tool of choice when it comes to text, and being able to combine those things to separate that from the noise is really what I want to describe to you today, right? How to kind of do that using time series along with Wordstat and doing surveys and things. So it kind of goes back to when I started, in fact, my colleague, Dale Van Leeuwen, who's co-owner of the tool that we've got here called PRIMS. It's called Project Risk Identification Measurement Mitigation System. It's a heck of an acronym, right? But it started out in 2008 when I was going through these large projects, and I realized that they're almost like social science experiments. And to stay ahead of problems, the only way I could do it was to engage the team. So I came up with this tool, and I would survey my team members, some cases large team members. What are the risks that you see, right? And also, by the way things are going is kind of like the doctor's pain scale. Are we on track? Are we going to have minor issues, or do you see a real disaster coming ahead here? And so correlating these kind of feelings about the overall performance of the project with a certain risk became one of the things that I did. And so, of course, this is text. It's free open text, right? Now, eventually I benchmarked these, and I'll show you some of the results of those over the years. This goes back since 2008. But you can see that already that, this idea of extracting beliefs from people and what's bothering them, and getting this and analyzing this into categories allows you to kind of get your arms around this. And so then I look at risk levels and see if I see turning points either up or down. And I try and say, okay, what is the risk that seems to be associated with this? And if it is, I need to get ahead of this as a manager. And you can apply this to almost anything. I'm just applying it to project management at the moment. And it kind of goes along with this idea that within companies, you have this large amount of unstructured data. This is one example. You have emails, you have all sorts of things. But when you go to, like when I teach my students, traditionally machine learning or whatever, they focus on structured data that's in Excel that kind of is there readily from like systems, IT systems, and so on. But this is kind of another demonstration of capturing unstructured data, text, in a business setting and how to make it useful. And so from my experience, my database that I collected and I analyzed, the analysis I'm going to show you is several years old, because I've had this data since 2008, and I do it with every, I'm still working, about 40 projects and about 2,000 risk statements, putting that together. So what happens then is that at a high level, and I'm going to get into an exact project example, but what you do is that when you go and you get statements, you can use the Wordstat dictionary, right? And its topic modeling capabilities and its ability to capture phrases out of very, very diverse statements and categorize them and then quantify these things, right? You can see how many mentions in this case I've got here through 40 projects. These are things that kind of come out that through topic modeling. And then what you could do is you can, like, this is looking at, kind of a visual display. I can see that those projects that I worked on that tended to be more successful versus less successful, these would be the more successful in orange, and I'll get rid of all the projects that never got out of the planning phase. But if I look at these, I can see that the density of mentions of these items here were the projects that say didn't meet their schedule objectives within 35 days is blue, right? They didn't meet their objective, but if they met their objective schedule-wise, in orange, you'd tend to see that you can start to discriminate and possibly predict. It becomes kind of a predictive tool to say, look, if people are saying certain things, then that is predictive of failure. I better do something, right? And that's becomes very useful. So, and I use this case study with my students in terms of taking outcomes as positive or negative and looking at various factors here and letting them do machine learning models. Like, as it turns out, technical problems, very high resource, not available resources, but also the number of people that participated in these surveys was the most predictive at all, meaning that people want to tell you when something is going wrong. They'll participate in your survey, and it's highly predictive. And you can see here from this confusion matrix, and all this is just saying that what I predicted versus what actually happened, it's quite predictive, right? You can use this kind of thing, and it's very useful because it gives you confidence that certain risk factors that you're seeing are somewhat predictive of failure. So you better, if you're a manager, take advantage of this, right? So that's kind of the overall design of this thing. But what I want to do is show you a case study example of an actual project that I used with Wordstat. And it's not one of my best performances as a project manager because it represents what I would call a failed project. And I call it the forecasting project. And it was a case study that I write up. I still do a little bit of project management training, but less so than I used to. And I use it as a case study and saying, look, this is what can happen where you're using typical project management procedures, but you don't really go the extra mile to manage risk. So essentially what it is, it's a study of an application development project for a very large company. It was had the solid backing of management. In fact, it was almost a dictatorial style of management that it was going to be designed this way. And there were certain warnings coming along the way, but we just weren't able to harness management's attention to say, you better change. You need more flexibility. It was highly granular design, asking people to take many, many manual steps, when in fact, it just was the team, the users that were going to be using the system didn't want it, but nobody wanted to speak up. But the interesting thing about this voice of the team survey, it started to indicate early that things were not really going that well, but the culture of the project was such nobody wanted to hear this kind of bad news, okay? And it led to a bad outcome. So here's the interesting thing, right? As a project manager, I had a schedule and I looked at all my activities being completed, right? I was right on track, right? I mean, all the signs were that this project is performing well. But then when the sponsor changed, this person that was driving it, all of a sudden the team started bailing. And we were left with one group that wanted to go. But then what happened was that the performance of the system didn't pass testing. And those performance problems are what killed the project, and they lost about $800,000. Now, you could argue that, okay, we lost $800,000, but we probably saved millions by not going ahead with this thing, right? You could argue that, but I'm a pretty self-critical guy, and I'm saying to myself, wait a minute, we let it get this far. Could I have early on, even earlier, given insights here that would have saved all this here and all this anguish and grief, and just made a design change that would have allowed us to be successful, right? That the business would have wanted. And so I asked myself, well, could this do us? And could text analytics help us? So what I did, I'm showing you as a retrospective, the interesting aspects of this, in that I text analyzed all the relevant emails. And I took really, I think, mainly email titles, because there were so many emails. It was a very large project, but I took the titles. I also took the action item logs of what people were supposed to do, and problems and defects, looked at those. But I also took a voice of the team risk sentiment tracking. And what you're going to see is some interesting, I find it interesting, some interesting relationships here. So when I go and I take all this text from risks, right, that I had, risk categories, words and phrases, and this is several versions before of the current Wordstat version, right? I was able to kind of come up with these dictionary categories and subcategories using Wordstat. And then what I did was I made sure, because the tool that we use is time-stamped, all of these risks, every risk brought in had a time stamp to it, right? And Wordstat, as you may or may not know, allows you to bring that in as a variable, and it's a very, very important variable. So what you can see is that the number of risks coming in tended to, early on, everything started kind of the forming, storming, performing, phase of a project. There's other analogies that are not so pretty, but you get this, and you can see the number of mentions, total mentions, and then during testing, you could see the number of risks really escalated because they were running into problems, right? So it was kind of, these are, look at the total mentions here. But so what that means is, and I'm showing here, is that when you bring something like this in and you want to have a time domain in it, you timestamp your text variables, right? And then Wordstat readily accepts the timestamp as a variable. And so you have the text, which is your document or a short string in Wordstat. And then you have your timestamp. So those two variables are critical for this. And so here's the interesting thing. So if I look at all the defects and action items that were coming in, what I have here is the total, you can see, and I have what the users were complaining about. And those were reports. They wanted their reports, right? They didn't see them, they weren't coming, and that's what they complained about. And, but the thing that killed the project was this little sliver of red over here, right? And so that's a very, very interesting insight you're going to see. And that is that this concept of the wisdom of the crowd, what everybody is complaining about, that whole thing is, hey, the most mentions are the most important. Well, sometimes it's that lone voice that has a very, very lot of experience and can start speaking up and say, hey, wait a minute, you better consider this. But then if you crush that person, right, and say, don't ever bring that up again, then it goes away, right? And this is kind of the way it was dealing with certain action items and so on. But if we also looked at email lines, and I took a look at the emails, I see a different pattern of words, of number of emails. And you can see early on, there are a large number of emails in the initial phase, and then during the requirements, but then the emails tampered down during the design and build phase in here. So they used a different form of communication, but what you see is also this kind of system performance, which I view is the risk that actually killed the project, that was tied to so much manual behavior. But then if I look at that as email subject lines, but then if I look at the voice of the team, the risks, what I see is more of a consistent pattern showing there were team members that were seeing this coming all along, right? They were seeing this kind of happening, that this risk, and of course the risk became real after they went through user acceptance testing, when they actually had to load data into the system. And so this provides, so head scratching a little bit, right? Because it's telling you that it's not just the total quantity at a point in time when you analyze information. Sometimes important information can be a lone voice that's coming in that can be useful. And so the question is, especially if you think about the drawing I gave you, I showed you of Escher, the idea of the birds, right? They come in very vaguely early on, and then they mature and move on. The question is then, how do I separate the signal from the noise? What I don't want to become is the Chicken Little project manager and say the sky is falling, when in fact it's not. I want some sort of evidence. I want some sort of vehicle. And because I'm a statistician, I've gone through several iterations. I went through in 2008, because I'm an economist too, and I went through wagering, and that failed, and so on. But I finally got through cryptography using Bayes' theorem, a method that we use today in this tool. And if I was to take, for instance, in just the standard dictionary of Wordstat, reporting, resource availability, you can see system performance is mentioned in aggregate at the end, but it was during the entire life cycle that system performance didn't score that high, right? Because the other things, kind of the noise just shook it out, all right? So the question is, when you get these threads coming in of text, how do you kind of spot those things and detect it in a defensible way? And so, here's the example of like, you can apply this to, social media and so on like this, where you get all sorts of things. I just took a doctor's thing here, and I've got a date, I've time stamped it. And I basically then brought it in, and I made sure the timestamps came in, right? And I brought it in over here in Wordstat as a date. So this is coming in as my text. This is my date. So this is the vehicle of bringing it in for anybody that might have a question. But here's getting back to the noise or to the concept of how do you separate signal from noise when you have time? Well, the answer that I finally settled on after a lot of trials and tribulations and failures, you could argue, in terms of getting people to try and wager. It sounds funny, but it's the only way I could compute odds, right? It was through wagering, and it didn't work. And so, but then I stumbled on this, and this is I.J. Good's book. It goes back to 1950, and Good was Alan Turing's statistical assistant at Bletchley Park. And as you probably know, even in Wordstat, they use naive Bayes as a machine learning vehicle. Well, this is tied to Bayes' theorem as well. And this is kind of a key part of Good's book that I read very carefully. And essentially what he does, they've came up with at Bletchley, in order to break the German code, the naval code, they basically performed hypotheses tests to see if they would come up with things that would compare if they had signal versus random. In other words, if they felt they had a way of prediction that was coming up to decide on what wheels of the Enigma machine they did. And so he wrote all this up. He hid it. He never talked about the fact that they used it for cryptography. He just hid it is like bird watching and things like that. And that was how I.J. Good got away with it. And so what I did was I took, and by the way, everybody's still there, right? You can hear me? Tony?
I'm on mute, but yes, we can hear you.
Okay, all right, right. Because my phone was buzzing and we got a little.
No, you're good. And everybody's chiming in on the chat. Yes. Okay,
great. So anyway, I took Good's Bayes' theorem method, and then there was another guy named E.T. Jaynes in 1958. So in statistics, as Normand will confirm, old does not mean bad, right? Old sometimes, guys like Carl Pearson and people go all the way back to the 1900s, right? Early 1900s. Some of the stuff they've done is very powerful. And so what I did, and we built into our tool, and Dale, my partner, is on, is that when people were coming in, right, we came up with this method using Bayes' theorem to say for a particular risk, when is the point that it looks like it's no longer noise? It's actually signal, right? And so we have this vehicle for these kinds of risks that we benchmarked. And so what I did then is I went back and I did a retrospective. And I took this project that I was project manager of that failed, right? And I said to myself, let me take some of Good's thoughts and apply this. And so I looked and I said, what was the earliest week that I had adequate evidence that this project was in trouble because of this risk? And so without getting into Bayes' theorem too much, right? I took the hypothesis test and I took the odds and the probabilities, and it was sure enough by week 4, I had adequate evidence to say that this is a likely problem. I need to investigate this more, and I need to bring this to the attention of the sponsor. And when you have something like this, now this is where I took it, and I just did this in Excel, not in our tool, but I took this and it shows that, there was substantial evidence by week 4 that using Good and Turing's method of this, and that was outlined in Good's book, that, we had something. And this would have been sufficient, I think, to bring the sponsor to the table to say, look, there's real concerns here that are coming out. And we have some evidence of people that are smart, that know what they're doing, that have been through this before, that are saying your design needs to be simplified. It's too complex. But without any kind of evidence, right, it just becomes your opinion versus another person's opinion. So this is a way of potentially capturing this kind of thing. And, and this is the example in Good's book where he took rolling dice. So in other words, the more times he rolled a die and it just gave a biased number, the more confidence that you get. And so what happens is, you get this kind of, the number of times you get it over time, eventually it hits a point of probability that it's a very defensible kind of a concept. It's a defensible worry, right? And so over the years, what we've done is that we've taken this and we benchmark these risks, and we have our own tool that takes these, that allows other risks and everything. But we have this in there that allows people to use this. And, this is a tool, this is a commercial tool that we put together on this. So a couple of lessons learned, right? And what I would say on this, the wisdom of the crowd kind of thing is, when you look at just the raw numbers coming in, if I was to look at a control chart as a statistician, well, it didn't really get bad until like testing, right? You could see this. This is a Q-sum chart that kind of shows differences. And so you can see that things started getting really bad around this period based on the number of risks that were coming in. But by looking at discerning at that lone thread kind of coming through, I could have gotten much earlier if I had done that, right? And so I think that's the message of it. And so, I'll show you just a couple of slides. I know maybe I talk too fast, but I went through it pretty quick, and I'll be glad to answer questions and get any level of detail you want. But these are the people where it came from, right? In Good's method, right? What they were trying to do is break the Enigma code. This was the naval machine, the Lorenz machine. These are the people that did it, and this is I.J. Good, and here's Turing and these people, and this is how it was used by the Germans in the field. And they also had a Tunney machine that was based on VoT, whereas the Morse code was for this one. And I'm not going to go into how the machine worked and so on. These are slides I use with my students just to give them a little bit of a background how it worked. And it was used with letters, not really with words. So that's kind of the message that I have, the importance of potentially time series. And one of the things that if this is of value to you, the ability to extract data and then have this date field kind of come in and then bring it into Wordstat. This is where I think a lot of work can be done on making this easy, especially like with people that, I'm generalizing now to social media and things of that nature, but the ability to interface with some of these like social media platforms that will give you the dates on things, but you have to do a lot of manual manipulation to really bring it, at least for me. It could very well be that, people like Norman have already got this figured out and it's trivialized. But, for me, it was something that I think the ability to bring this in. And the other interesting thing about it, too, is that the machine learning capability in Wordstat is based on one of the methods that's available is naive Bayes, which tells me that the Provalis teams understands Bayes' theorem very well, right, to be able to do that. And so it's, it kind of, Bayes and text have historically gone hand in hand for a long time. And it related to letters, not necessarily words, but still Bayes' theorem and text and being able to put those together is historically been a very close connection. And so I think this kind of leads that way. So anyway, without over speaking, and I don't hope people, I'm not selling short, I'm only speaking for 30 minutes. This is what I do, and I found it to be very, very helpful. So anyway, does anybody have any questions?
Yeah, John, thank you very much, John. That was great. So if you have a question that you would like to ask, please ask it through the chat section on the bottom right of your screen. So a couple of questions.
Sure.
Is anonymity a feedback necessary feature in Voice of Team?
Wonderful question. The answer is yes, it is. It absolutely is. Now, because we're the owners of it, we can get a report that shows who did it, but we never really reveal who said what. And it is important because people will hold back, especially in a project like the one I just described, where you could feel like you're damaging your career. So it is, and that is a feature that we have in this. Absolutely. Great question, by the way.
Okay. How did Wordstat topic categories, how are they transformed into probabilities?
Yeah, you can do counts on those, but let me try and figure out how to answer this the best. So if you're thinking about probabilities using Bayes' theorem, what I felt that it's very project specific, right? And so I gave you one example of a probability. Now I use different distributions. I use the Poisson distribution. I use the Bernoulli distribution. I've tried different methods, but whoever brought this question up raised a very, very powerful statement, because using Bayes' theorem, I tend to use Jeffrey's prior, which is a non-informative prior, meaning it's just as likely to occur as not to occur on a project. And so what I do is I don't seed it with any prior information, but what I do is say that the chances of a risk, any particular risk coming in, is approaching about, like 35, 40%, something like that, for certain categories, less likely for other categories. Like if I was to look at, and just go in and show you. It's a wonderful question, and it's, I could probably spend too long of a time answering it. But the thing is, it's where you start. I use a 0 dB here. I could have negative if I wanted to, if it was very unlikely for a particular risk to come in. But I always start at 0 because I don't have projects vary so much. So I just use a non-informative prior where I just started at 0 at this point here. But then what I do is I limit it to, when I have odds, I limit it to about 20 dB, which is getting to about 90% probable based on the number of feeds that I'm getting. But if we look at the question asked in another way, what you definitely see here is that there's across projects a greater reporting, right, for certain risks other than others. So for instance, the most frequent risk ever mentioned of all is the idea of not enough resources, people not showing up. And that usually varies with the size of the project. And if the people are having to do two jobs, serve the business as well as others. So what I will do is, maybe if I will adjust probabilities based on that. But for our tool, we put a nominal probability in there. I don't remember it off the top of my head, that separates the likelihood of that actually happening versus randomness of it not happening. And so I go for, in other words, coincidence. So I didn't fully answer it, but maybe you get an idea how I'm thinking about it.
Yep. Yep. Thank you. And if any, we can, maybe there'll be another sub question later on.
Yeah.
How do you navigate confidentiality, easy for you to say, easy for you to type, issues if we're managing third-party projects, GDPR issues and the like?
Third-party projects. Well, if I was to look at the benchmarks, the way they tend to come out, system performance, technical challenges. I guess the way that it is managed is more not through the system, but more through careful revealing of the answers that you get. So typically what happens is when you've got a survey of any kind, and you're showing the results to people, what you try to do is to say, this is the area, and then what we allow is for people to type in their own explanatory remarks. So in other words, underneath, when you type and you select a risk category, you can type in specific wording under there. And if it is an outside third-party organization, their name will typically be mentioned. But what you try to do as a project manager, things happen, and you want people to be accountable, but you don't want to beat them up and embarrass them and humiliate them and use it as a tool for that. That's not productive. But that's almost a kind of a art, so to speak, or it gets less into the tool perspective, more in just to managerial style. But the way we capture and get specificity is that when a person clicks on a category, it opens up a text box so they can explain it. And then you've got that information and you can refer to that. Fair enough?
Yep. Lawrence, I'll get to your question in a bit, but I've got a few questions here first about dictionaries. Could you have used or could you build a standardized or a widely used risk dictionary?
Yeah. And the constraining factor is like, I'm showing you 40 projects, right? The result of that over a period of time. The problem is with projects is some of them are very long and there's only so many projects you can do in a career, right? So these are projects that I've had some affiliation with. But if it was like like the Project Management Institute or something of that nature, where you were able to capture cooperating organizations and put it all together, it would be perfect. It'd be perfect to do that. Yeah.
Okay. Do you have any advice on dictionary building in general?
Yeah. Let's talk about something, right? So if I go into, let me just pull in maybe a different file. Well, I don't necessarily want to jump. All I want to say is this: the extraction capabilities of topics and phrases in the new Wordstat is very, very powerful, right? Because not only does it give you the most frequent mentions, but it gives you like subcategories, the way it's built in under here. And so what you can do is, right, of course, you can just export these topics and these phrases. You can put them right into your categorization dictionary, and you've got them. And then once you've got that, you can take categories and then you can put them into the right level of specificity that you got. So when you are let's say you're kind of doing, and I don't have a project really loaded here very well, but let's say I wanted to add, maybe, let's see, I've got frequencies, extraction here. Let's see. Well, I don't have anything shown to add, but the point is that what you can do is you can very, very easily do it, and it facilitates it. Just let the system tell you what it's doing, and then very carefully decide what subcategories you want that fit into there, and that applies. And I'm afraid if I open this and I start scrambling around, trying to find a Wordstat file, I'd mess up everything. But
No, that's okay. That's okay.
yeah,
I mean, I think that's.
but use the extraction. That's very, very powerful. And look under topics for topic modeling and phrases and bring those in. And I think that's a great first start. And then as you get them, you'll go down the list and you'll say, okay, that's really just another way of topic 1, topic 2. And then when you export it, you just drive it under that as a subcategory.
Okay.
Fair enough?
Yes. Do you take into account how many people mention a potential risk, their experience or qualifications?
The system is not as sophisticated to do that mechanically, but what I do, because I do have access to who said what, and I know the different roles on the people, I will go out of my way to kind of talk to them about what they see. And if they convince me that that's not just an arbitrary remark and I'm missing something, then, that's the way I do it. So I do it kind of out of the system, but I do use that as a rationale to go contact people and talk to them.
Okay. Do you find that graphical displays of results are often a clinching factor in persuading senior staff that it's not too early to act?
It's the only way to do it.
Inflection points and line charts can be very telling.
It's the only way to do it. I'm exaggerating slightly, because you got to keep in mind that when you have a project, especially a large one, it's almost like a force field analysis. You have different interests, right? Some interests are to keep it going. Some are to stop it, the project. Some are to make changes to the project. Some are to add scope. So what happens is, even if you're the project manager, you are only one individual and you have your own interests. And so what senior management, the sponsors of the companies see, they need some sort of a measure, such as what's described here. That's the reason for going to the trouble of showing that kind of a chart like that, because that's what gets people's attention. And it has to be very simple, and it has to be very easy to understand, and then they will react. And it's absolutely essential. Among other project metrics, that kind of a thing is absolutely essential, because it's just your own voice is not enough to really make a change.
Okay, thank you. Next question. It's also from Lawrence. Has anyone, as far as you know, used your naive Bayes approach in healthcare? It seems to me that your general approach might be applied to the development of disease, with the possibility that you could recommend intervention at an early stage.
Absolutely. And and the only downside of this is that when you start talking Bayes' theorem, people's eyes roll in the back of their heads. It's very, very hard to communicate what you're doing. It's a little bit like this. Let's say, you get in your car and you hit the gas pedal. People know when they hit the gas pedal, the car is going to move forward. They don't know that the gas pedal is mechanically connected to a carburetor. I'm showing my age when I say carburetor, but
fuel injection,
right? They don't see all the linkages, right? And so this kind of has to be presented in a way where you don't get into the theorem itself, but it is extremely powerful. I mean, I've gone through many iterations of this, almost like a career. You can imagine, this has always been part of me since 2008. I mean, but you're absolutely right that, and I think that is the power of really, and it's too bad that I.J. Good's book is out of print. Now, that said, I have corresponded and worked with some of my statistical colleagues who look at things a little bit more modern, and they'll use control charts more readily. And what they might do is show on a control chart, rather than what I'm doing here, what they will do is kind of like, well, it's like this one, right? they'll do this, except they'll kind of have graduated lines for confidence intervals like that. And so something of that nature it kind of does, but I think a more modern view is that people will do it that way. But I've elected to stay the way I do it because it just, I think it's just more provable. I mean, I go back to, Bruno De Finetti, and Frank Ramsey, 1927, and so on, saying that if you don't follow the rules of probability, you can be beaten by a competitor. And so I try to keep it as probabilistic, tied to probability theory as I can. And that's the way I teach it to my students. And I don't know if my students are using it or not, but they learn this. So anyway.
Okay, well, thank you very much. It looks like that's we're kind of out of questions, but it's been very instructive. Thank you very much, John. Typically, do you have any sort of final words, wrap up thoughts, et cetera, et cetera?
Well, all I can say is, I have been a longtime user of Wordstat, and I always look forward to the new ideas that are coming out. And I think that for those that haven't seen the newest release of topic modeling and the work with phrases and all the things that have been put in there, take a look at it, because that makes the dictionary building all that much more powerful. And, to the extent that, this is, you find this kind of thing interesting, I hope you use it, and let me know if you have questions. Feel free to, Tony, feel free to let him know my email address.
Okay, I will. Do you want, do you want to share it now?
Oh, yeah, sure.
Just verbally.
All right, john.aaron@milestoneplanning.net.
And Aaron is 2 A's.
Yes, john.aaron@milestoneplanning, all one word, .net.
Okay. Okay, well, thank you very much. And if anybody didn't get that, or has problems with the spelling, you can contact me at tony.ross@provalisresearch.com, and I'll be happy to forward that along to you. Can you see my screen, John?
Yeah.
Okay. So thank you everybody for participating. Our next Lunch and Learn is in 2 weeks, Wednesday, March 16th from 12 to 1. You can register on the webinar section of prevalisresearch.com. And the title is, What Can We Learn from 100 Novels? A Text Analytics Dictionary Approach. So look forward to seeing you in 2 weeks. Thanks again, John. And thank you everybody for participating.
Thank Tony.
Bye-bye.
Thank you, everybody. Bye-bye. Have a good day.